today everybody we are starting 9-3, polar and rectangular coordinates. So right now, what we're going to do is we're in this graph right here. I want you guys to understand we're going to take this point, which has an r and a theta. That's called a polar coordinate. All polar coordinates have what's called r, comma, theta. So right here, if I said 3, that means that you would be in the third ring. I'm just making more circles, all right? So
wait, but that's only 3 right there.
Oh, I'm confused.
Pardon me?
So it goes 1, 2, 3.
Right, and you're at 3 pi over 4. Now, by the way, in case you're wondering where 3 pi over 4 was, that is equivalent to 135 degrees. Quick review. Every time you jump up pi over 4 radians, that means you're jumping up 45 degrees. So how many pi over 4s do I have? 3. 3 of them. So if you multiply 3 times 45 degrees,
You
that
get
means you're at
135.
there you go. There you go.
Wow.
All right.
So smart. The answer was on the board. We just had to put it
Let me pre-apologize for anybody who's watching this video. Normally I don't do it in this class. They have a tendency to interrupt me when not asked.
I'm sorry.
Not us, Mr.
Marley, why don't you tell me how many degrees have I gone right now?
Just 1. I mean 0.
That's right, 0 degrees. How about this? How about right there?
That's 90.
Good. Now, how many more degrees do I need to go from 9?
45.
Yep, so go additional 45. That puts me right about in.
135.
There we go. So right here, from here to here, I'm going to highlight in a beautiful blue color.
Wait, it got kind of out.
Right here, I want you guys to write 135 degrees in your drawing. This section right here is 135 degrees. Now, this point right here, everybody, this point is at the polar coordinate 3, 3 pi over 4. Today, what we're going to do is we are going to convert polar coordinates to what's called rectangular coordinates. Rectangular coordinates are what you're typically used to. They go with rectangles, also known as squares. It's your Cartesian plane. So if you wanted to say plot this on the Cartesian plane, we're going to convert it to what you would plot on the Cartesian plane. So we're going to have, instead of r theta, we're going to have an x, comma, y that you're used to doing in Algebra 1. Marley, right there in front. All right, the next thing I want you to do right now is we are going to make what's called a right triangle. So I'm going to do this in a little bit different color here. I'm going to change it to blue. I want you guys to really pay attention to the right triangle that I'm about to create right here. I'm even going to shade it in a completely different color. I'll explain here in just a second. So right now, I want you guys to really focus your attention on the triangle that I just created on this polar coordinate grid. This triangle, everybody, if this is 135, that means this angle right here has to be 45, which means this angle right here has to be 45. So now, that lets you know you are dealing with what's called a 45 degree angle. Now, instead of using x, I'm going to say n for the length of the side, n for the length of the side, and n radical 2. I'm not going to say x radical 2 because I don't want to confuse you with it. So right now, n represents the length of the side of the triangle. Now, for those of you who have forgotten the properties of a 45, 45, 90, right now it's going to make a 45, 45, 90.
Mr. Coons didn't teach me.
Don't you throw him around.
Guys, that's not. You're right. He wasn't your geometry teacher, so you're right. He did not. If he was your geometry teacher, she would have taught you.
Actually,
So right now, when you guys are building this table, I want you to understand your R value that you have for your polar coordinate will always be this number right here. For us, our R value is the number 3. So R is here, theta is here. We're going to put the number 3 right there. In order to solve for n, you have to solve for it setting up this equation. You're going to write the n times radical 2 is equal to the number 3. If we wanted to solve for n, we could divide both sides by radical 2. Now, when you divide both sides by radical 2, those radical 2's cancel out. 3 divided by radical 2 is your approximate. That will give you an approximate value. Now, this is not your exact value. Some of you will remember that you have to do what's called rationalize the denominator. In order to rationalize the denominator, what do you have to multiply the numerator and the denominator? Not the reciprocal. Whatever's in the denominator, which is? Very good. Radical 2 over radical 2. 3 times radical 2 is 3 radical 2. Radical 2 times radical 2 is the square root of 4, but the square root of 4 is just 2. This, everybody, is what I would like you to put right here in your table on your right. 3 radical 2 over 2 and 3 radical 2 over 2. That, in this particular case, would be the lengths of the sides of our 45, 45, 90. This is the length of the hypotenuse, also known as the radius, the r value. Okay? So right here, think about our quadrants. Okay? Which quadrant, if we were in the rectangular coordinate system, which quadrant would I be right in here?
2.
That'd be the second quadrant. The second quadrant, everybody, good job. The second quadrant, everybody, will have a negative x value and a positive y value. So your final exact answer is negative 3 radical 2 over 2, and your exact value for y is 3 radical 2 over 2. So, what I'm going to do right now, these are your exact answers. If I said, what are your rectangular coordinates for 3, 3 pi over 4? These are your exact answers. Now, I've given you a formula. This formula helps give us our approximate values. So let's see what these approximate values look like. So I'm going to turn my calculator on. I'm going to type in alpha y equals, enter. I'm going to go negative 3 radical 2 over 2, and I'm going to press enter. And I get this negative 2.1. And then I'm going to say alpha y equals, enter. Type in 3 radical 2. Oh, that's not 3. That's not radical. It should be, yes. It should just be positive. Because it's going to be the positive version of it, right? Okay. Now, there are some formulas that I told you guys, right? And the formula, I'm going to take a picture, screenshot of this real quick. The formula was x will equal r cosine theta, and y will equal r sine theta. So right now, what I'd like you guys to do is write x equals 3 cosine, open up the parentheses, put 3 pi over 4. And then put y equals 3 sine. It's supposed to be sine, I apologize. 3 pi over 4. Now, when you guys type this into the graphing calculator, I want you to notice your mode will definitely have to be in radian mode because we're dealing with radians. So watch this. Here we go. 3 cosine 3 pi divided by 4, close parentheses, press enter. What did you get?
2.12.
You guys see right now. This was what? This was our exact value for x. This was our exact value for x. This is the approximate value for x. So what does, if I go back, what does x equals r cosine theta give you all the time? It gives you not the exact value, it gives you your approximate value. Now sometimes it will give you an exact value, okay? But if it's decimals, that means you have to find the exact value using your 30, 60, 90 or your 45, 45, 90. Okay? Now if I were to go back to write, not that one. If I were to type in 3 sine 3 pi divided by 4, what do you think that's going to spit out? For y value. That's your approximate value for y. Okay? So, in review, you need to know not only how to get your approximate values, you need to know how to get your exact values. The best way for me to teach you to do the exact values is to draw a picture and see where you guys are on the unit circle. Okay, see where you are located. Now, we're going to go do the next problem that's on your example, which is dealing with 20, negative 60. So you guys have this. Now, right here, did you guys see on your study guide, you see your exact answers right here?
Yeah.
What did we find our exact answer to be? Negative 3 radical 2 over 2 and 3 radical 2 over 2. So right now, I'm going to take a screenshot of this. Okay? We're going to make a new paper, new page right here. Q is at a 20, negative 60 degrees. This is your R value. This is your theta. I'm going to show you the exact same process, except this time we're not working in radians. Now we're working in degrees. So our goal is to take these polar coordinates and make them an X and a Y coordinate, which is a rectangular coordinate, not a polar coordinate. So we're going to start right here. Once again, we're going to start right here, and we are at how many degrees right there?
0.
0. How many do I need to travel?
Negative 60.
Very good. So right now I have to go not positive, I have to go negative 60. That's about negative 45. Negative 60 is going to be somewhere right in there. Okay? So right now I'm going negative 60 degrees. I'm not going to write negative 60. I'm just going to write 60 degrees. But we know we went in a negative direction. Okay? We're going to draw a nice little right triangle. From here you're going to draw straight up. There's my right angle. This triangle right here is definitely not a what? 45, 45, 90. It's going to be a
30, 69.
very good. 30, 69. So what I want you to do is write 30, 60, 90. N radical 3, 2 times n. Here we go. Now, I'm going to just draw a random 30, 60, 90 triangle. For those of you who are watching the video and have never seen a 30, 60, 90 triangle before, just talk to your geometry teacher and tell them that they failed. Just kidding. Don't tell them that. That would probably hurt their feelings. Right now, you're going to write n radical 3, and 2n, because the most likely case, that the teacher actually did teach you, just forget. N radical 3, 2n. By the way, what number did I say is always going to go right here? Anybody remember?
N.
Yep.
I mean R.
Yes. What is our value right now?
20.
That's right. So R is our 20.
And then we're going to have to divide it by 2, which means N is 10.
That's right. So N is 10.
Yeah. So then it's 10 with the square root of 6.
Boom. Now, you have all the information that you need. So right now, if you would please, right here in your picture, could you guys label this as the 20? So this point right here, this point right now is at what's called 20, negative 60. That's where this point is located. It's at a 20, negative 60. Is this in the rectangular form or polar form right here? Polar. That's correct. That's the R. That's the theta. Good job. Now if that's 20, what number is right here? What's across from the 30-degree angle? What number? 10. What's across from the 60-degree angle?
10 square root 3.
All right. Now, which quadrant are we in right here? Which quadrant?
Quadrant 4.
Quadrant 4, everybody. When you are in quadrant number 4, and you're in X value, you're positive. But if you're a Y value and you're in quadrant 4, you are a negative.
Yeah.
So right here, look, how far have I traveled? This is your X value. This right here, I'm gonna make a little negative sign right now. This right here is equal to your Y value. So what is your exact answer? Not in polar form, but in rectangular form. Your final answer is a 10, negative 10 radical 3. Now what I'd like you guys to do is watch you write X equals R cosine theta and Y equals R sine theta. And you're going to put 20 cosine 60, actually, make it negative 60 degrees. And then put 20 sine negative 60 degrees. Those TI calculators, take a look at what they keep on ticking. So right now, if you're working with degrees, guess what you got to change your calculator to? Degree mode. Here we go. I'm changing it to degree mode. I'm hitting the mode button. I'm going down to where it says degrees and pressing enter. Boom. Come on, work. There we go. Now, I'm going to go back to my screen so I can quit. And I'm going to type in, clear that up. I'm going to type in 20 cosine negative 60. And remember, sometimes I said sometimes when you do this, the answer becomes exact. Watch. It becomes exact. There's no decimals after, right? But if I do 20 sine negative 60, what did we got? We got a negative 10 radical 3, right? So what do you think this is approximately equal to? This approximate value right here. Yeah, that's our negative what? 10 radical 3.
I put 20 cosine negative 60, got like negative 19.
That's because you didn't change it to degree mode. It should be in degree mode, not radian mode.
Oh, okay.
So if you, that's good, because if you don't change it from one mode to the other, if you're in degrees, work with degrees. If you're in radians, work with radians. So hopefully everybody can see that this is the approximate value. So our final answer, everybody, was 10 comma negative 10 radical 3. This would be your exact answer for what? For x comma y. Your approximate value would be a negative 17.3 for x and y. And if you go back to your page of notes, look, the rectangular coordinates of Q are 10 comma negative 10 radical 3, which is approximately equal to 10 comma negative 17.32. This is what you're doing on the first 4 problems. Now, good luck.